Question number 8. It talks about enthalpy of sublimation. As we all know, the enthalpy for a chain of reaction is additive. Sublimation is conversion from solid to gas. It can happen in this way also. Solid can be converted into liquid in one step, and the liquid can be transformed into gas. This is the enthalpy of sublimation. In this reaction, it will be enthalpy of fusion, and this reaction it will be enthalpy of vaporization. Now, from Hess's law of constant heat summation, the energy change in this particular reaction will be equal to energy change, the sum of energy change in the other two reactions. So delta H of sublimation will be equal to delta H of fusion plus delta H of vaporization. The option A following. Okay. Sorry for question number 8 rather than 18. Question number 9. Which of the following is not correct? Delta G for a reversible reaction is 0. We know for reversible delta G is equal to 0. Delta G is greater than 0 for spontaneous reaction. This is something theoretically and practically incorrect. Delta G ought to be negative. For any process that occurs, the change in gas free energy should be less than 0. When for a spontaneous process, it should be less than 0. So it can never be greater than 0. So option B would follow. Question number 12. Work done in a reversible reversible isothermal process is given by this formula. Now I need to compare the work done when the process is done at a temperature of 300 Kelvin and at a temperature of 600 Kelvin. If we substitute data over here, if the ratio of volume is same for both cases, it would be T that will bring in the difference, and the work done in first case to the work done in second case will be equal to 600 upon 300 into some constant C into some constant C. All the other factors will be same. This C would get cancelled out and I would get answer to be 2. Work done at 600 will be twice of the work done at 300. This one work done at 600 and this one work done at 300 degrees Kelvin. 300 Kelvin. So work done at 600 Kelvin will be twice the work done at 300 Kelvin. And of course, since temperature is constant, delta U, which is equal to NCV change in temperature is constant, so delta U will be equal to 0. Question number 20. Which of the following statement is correct? PV equal to MNC square is an expression for real gas. Of course, this is incorrect. It is an expression for ideal gas. Real gas never comes into picture whenever we deal with any equation of this type. B option. At normal temperature and pressure, most gas behave nearly as ideal gas. That is basically incorrect. Real gas behaves as ideal gas at low pressure and high temperature, not at normal condition of temperature and pressure. Third, molecules of real gas have both volume and mutual attraction. This is correct. Real gas has volume, in fact molecular volume, and they do have attractive forces within them. Question number 22. It is a graph for Charles law, the isobars of Charles law. V by T equal to constant, and we all know that constant is inversely proportional to pressure, the pressure on which the experiment is carried on. So among the following graph, as pressure would increase, the slope of the graph would decrease. As pressure would increase, the slope of the graph would decrease. So P1 will be greatest pressure, followed by P2, followed by P3.